Okay, here we are at section 8.3, factoring trinomials. Let's see, what does factoring really mean? Have you ever wanted to be on a game show? Of course you have. Who hasn't? Now it's your chance. You have been asked to be on Math Time, a game show where all questions are math related. Do you want to play? Of course you don't, but here we go anyway. Let's do it. Follow the instructions below and let's begin. So let's go through this together, shall we? The game show consists of 2 rounds. Round 1, you'll be given a question and must select the correct answer. For round 2, you'll be given an answer and must select the correct question. Let's go. Round 1. What is 3 times 5? 15. Oh, yeah, okay. Clicked it right. Cool. Great job, right? We're going to click through this. We're going to do this together. Hopefully you guys know how to answer some of these questions. Did I hit next yet? Okay. Which of the following is the product of 3 and 3? Now that means what is 3 times 3, right? Product is multiplication. So 3 times 3 is 9. Nueve. Here we go. Submit. We got it right. Next. 2 for 2. What is negative 2 times negative 4? So again, multiplication. Keep in mind that a negative times a negative will be positive. So it's either going to be positive 6 or positive 8. But a negative 2 times a negative 4 is going to be a positive 8. Submit. Got it right. Let's go. Next. What is the product of 7 and negative 6? So multiplying these two together again, 7 times negative 6, it will be a negative number. And it'll be negative 42. Let's go. Okay. Hopefully you guys can do some of this multiplication. This is just kind of a warm-up, if you will. The product of these two numbers is 15. Okay, so which two numbers basically makes 15 when multiplied together? Remember, it's product. So the product of these numbers is 15. So is 1 and 3, 1 times 3, 15? No. Is it 3 and 5? 3 times 15? Or sorry, 3 times 5 make 15? Yes, it does. The other ones are wrong because 5 times 15 is not 15, and 15 times 30 is not 15, right? 3 times 5 are the numbers that multiply to make 15. Submit, got it right. Let's go. Next one, number 7 out of 10. The product of these two numbers is 9. So what two numbers multiply to make 9? 1 times negative 9 is not 9. 3 and 3, that is, booyah. 6 times 3 would be 18. Negative 9 times 1 would be negative 9. So we want a positive 9. That is 3 times 3. Submit. Got it right. Let's go. I preemptively said got it right because I'm smart. All right. The product of these two integers is 10. So what two numbers multiply to make 10? Tricky one because 2 and negative 5 would make negative 10. 5 and negative 2 would make negative 10. Negative 10 and 1 would make negative 10. But negative 10 and negative 1, double negative, makes a positive 10, which would be our answer. There we go. Submit. Got it right. Let's go. The product of these two integers is negative 8. Okay, so what two numbers multiply to make negative 8? Negative 2 times 4. That sounds like a good one. 5 times negative 1.6. I don't know what that is. We should probably grab our calculators and do it, though. 8 times 1 would be a positive 8. Negative 16 times a negative 0.5 would be a positive 8. But what's 5 times 1.6? Does anybody have a calculator? I don't see why 5 times negative 1.6 wouldn't be it. Can there be two answers? Negative 2 times 4 would be negative 8. Oh, integers. Aha. Ha 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 ha. Integers. Integers is whole numbers, not decimals. So even though 5 times negative 1.6, this is why you read the directions. Okay, 5 times negative 1.6 is negative 8. They are not integers. Integers are like whole numbers and like negative whole numbers. So that's only going to be option A. Yes, submit. Got it right. Let's go. And then, oh, we got 8 out of 8 correct. Let's go. We don't need to restart. Let's move on. All right, so you get the idea, right? Factors are things that multiply together. In the game, you multiplied in the first round, then factored in the second round. So it's opposites, right? Factors are two things that multiply to make a certain value, or it could be 3 things. It's just whatever gets multiplied together, those are the factors. And then the product is what the answer is. So when you talk about 3 times 5 equals 15, 3 and 5 are the factors because they're what multiplies together. 15 is the product since that's like the answer, right? So we're factoring. So we're looking for the things that multiply together, like the 3 and the 5. All right, let's look at our next page. It didn't work. Let me try this again. This is the problem of doing it midday on a Monday. Let's go to page 2. There it is. Okay. Factoring trinomials by grouping. Okay, there is a systematic approach to factoring trinomials with a leading coefficient greater than 1 called factoring by grouping. Does that sound familiar? It sure does, because we factored by grouping in 8.2. If you need a refresher on factoring by grouping, select the water bottles. We're going to pass on that, but if you need it, there it is. Before you see how you are able to use this concept of factoring by grouping to factor trinomials, let's make some important observations. Click it. Take a moment to multiply these two binomials on your paper. Okay, let me take my paper out. My paper is over here. Whiteboard. Okay, so we have 2x plus 4. Oh, let's just go away. Thank you very much. Let's make a new one. All right, so we had, I don't want you, there we go. We have 2x plus 4. And what was the other one? The other one we had was x plus 3. So 2x plus 4 times x plus 3. Now, when you multiply these together, you FOIL. So we're going to do first term times first term. So 2x times x would be 2x squared. Then outer terms, so 2x and 3. 2x times 3 is 6x, so that's plus 6x. Then inner terms, so 4 and x, 4 times x. 4 times x is 4x. And then last term, so last term here, that's 4 times 3. That is 4 times 3 makes 12. There we go. Now you might notice that, these two like terms can be combined together to make 10x. So our final answer would be 2x squared plus 10x plus 12. Remember, this is just adding two like terms together. It's not multiplying them. It's just 6x plus 4x to make 10x. But there you go. Now, what we're going to be doing in this section is we're going to be going backwards, right? Remember, the things that multiply together are the factors. So 2x plus 4 and x plus 3 are the factors. And the 2x squared plus 10x plus 12 is the product, because that's your answer. But when we are factoring, we'll be going the other way. So we'll have the final answer, and our goal is to factor it into those two factors, right? Kind of like the 2x plus 4 and x plus 3. So our answer is going to look kind of like those. Okay, just a heads up. All right, so we've done that. There's the work that we just did. We observed that 6x plus 4x makes a 10x, right? All right, now if you multiply the leading coefficient with the last term of the trinomial, you get 2 times 12, which equals 24. Now think of two numbers that multiply and give you 24 and add up to give you the middle term of 10. So let's go back to this, right? So notice our answer, remember, was 2x squared plus 10x plus 12. What you need to pay attention to is the first and last coefficient, so the 2 and the 12. The 2 in the very front, the 12 at the very end. Okay, normally we call this quadratic, a standard form, quadratic, and we call those numbers the a and the c number. The a being the first number in front of the x squared, and the c being the number at the end. Now, if you multiply those together, 2 times 12 in this case, we get 24. Okay, that's our target number. Now, the question it was asking was, hey, it asked what two numbers multiply to make that value of 24, but also the same two numbers that add to make that middle value, which is 10. The b value, our middle value, was 10. So there's a pair of numbers that multiply to make 24, and the exact same pair of numbers that add to make 10. Can you think of what they are? The answer here is 6 and 4. 6 times 4 is two numbers that multiply to make 24, but the same two numbers, 6 and 4, add up to make 10. This is the key to factoring. is going to be solving that little puzzle, finding two numbers that multiply to one value, but the same numbers that add up to another value. And I'm sure we'll practice that a little bit here, but if we don't, I'll make sure we incorporate it in a bit, okay? So let's work through another example. Okay, they have their example. And, well, here. Okay, before we get to their example, let's practice a little game, because this is a very important game, okay? So let's say I had a trinomial that was, let's say, 2x squared plus, let's put the last number as 20, and then this number as 13x. Okay, so let's say we had this trinomial, right? Remember, ax squared plus bx plus c. I need you to understand what the a and the c are. So we want to know what a times c makes. A times c, 2 in this case and 20 in this case, are the a values and the c values. So 2 times 20 in this case is going to equal 40. Now this is our target number. What I need you to do is find two numbers that are going to multiply to make 40, but at the same time, those same exact two numbers add up to make the middle number, which is 13. So, gotta put a plus sign. So in general, our rule here is going to be two numbers that multiply to equal whatever a times c is, and the same two numbers that add to equal the b value. So this is kind of the puzzle we have to solve. So in our example, we have two numbers that multiply to make 40, and the same two numbers that add up to make 13. Now, we just used 2 and 20, 2 times 20, to make 40. However, 2 plus 20 does not make 13, so we have to find a different pair of numbers. So what other numbers? Maybe 4 and 10, right? 4 times 10 makes 40. However, 4 plus 10 makes 13. I'm sorry, 14, not 13. So that's a problem. So what other numbers do we have? What numbers multiply to make 40? Well, 8 times 5 multiplies to make 40, and 8 plus 5 adds to make 13. So 8 and 5 would be the numbers that we would use here, okay? So let me practice again, because this is one of the main things that people struggle with this section, and this is the part that I think we need to practice the most. So let me give you another trinomial. Let's say we got 3x squared. Let's say I have minus, let me put a number at the end here, make this easier for me. Let's put 9 at the end here. No, let's put 10 at the end here. And let's say I've got minus 11x. Okay, so remember the puzzle, okay? Two numbers that multiply to make whatever a times c is, and the same numbers that add to make the b value. So a is 3 and c is 10. So when I multiply those together, that's going to make 30. So I need two numbers that multiply to make 30. And my b value is negative 11. Now keep in mind that minus sign does mean it's negative. So here's a good question. What two numbers multiply to make 30, but add to make a negative 11? Now this is kind of tricky, right? Because numbers that multiply to make 30, let's go with this, right? Let's start with some ideas. Let's pull up some ideas. So we know obviously 3 times 10 makes 30. However, 3 plus 10 certainly does not make negative 11. So 3 and 10 are bad numbers to figure out here. So let's keep thinking. What other numbers make 30? 15 and 2, right? 15 times 2 makes 30, but 15 plus 2 is not negative 11, so it can't be that. A good go-to would be 5 times 6. 5 times 6 makes 30. However, 5 plus 6 is a positive 11, not a negative 11. So what's going on here, right? How on earth are we going to add numbers and make a negative number out of this? And the quick answer for that is that these two numbers that we're searching for are both going to be negative, because a negative number times a negative number gives me a positive 30, but a negative number plus another negative number makes another negative number. So in this case, our answer would actually be a negative 5 and a negative 6, because the negative 5 times negative 6 makes a positive 30, and a negative 5 plus a negative 6 makes that negative 11. So in this case, negative 5 and negative 6 are the answers we were looking for. Okay, so that's the puzzle we're going to be doing a lot of. And I'll work through these examples. We'll do more of them. But I want to give you kind of a refresher on that. So factor completely. 3x squared plus 13x plus 12. Let me put this on my paper. 3x squared plus 13x plus 12. Okay, the first thing is to check for a GCF. Is there a GCF? Do all the terms have something in common that we can divide by? The answer here is no GCF. Okay, the 3 and the 12 are both divisible by 3, but the 13 is not. So we can't divide a 3 out or anything. They don't all have x terms. So there is no GCF in this one, so that's fine. So what step does it want us to do next? No GCF, right? Split the middle term. Okay. So here we're talking about that puzzle that I was referring to, right? And they've got a complicated table here, but let's go back to my puzzle, right? So when you're factoring these trinomials, you have to consider this puzzle. What two numbers multiply to make the a times c value, the same two numbers that add to make the b value? It's always going to be set up like this. This is kind of a go-to way of setting it up. I've also set it up differently from other times. Rather than writing it out like this, I've made like an X chart where I say a times c and b value here, and then I figure out what those numbers are over on the side. It's just a different way of organizing it. But for now, let's just stick with the basics. Say so we have it's going to be set up this way every time, right? You just have to change a times c. Now in this example, a is 3 and c is 12. So 3 times 12 is going to be 36. So that's my value up there. The b value is the number in the middle, which is 13. Nothing to change about that. So what I'm looking for is I'm looking for two numbers that multiply to make 36, but the same two numbers that add to make 13. Now there's, again, some options. You can practice, play around a little bit, but let's see, 36. I know that 18 times 2 is 36. However, 18 plus 2 is not 13. So I can't use that, right? Some of you are going to be faster at this than others, and that's okay. Let's think about 3 and 12 that we use. 3 times 12 makes 36. However, 3 plus 12 does not make 13. So I can't do that. Remember, it has to be the exact same numbers for both parts of this, for the multiplication and the addition part. So what other numbers multiply to make 36? Well, 9 times 4 makes 36. So 9 times 4 makes 36. Let's try that. 9 plus 4. 9 plus 4 is 13. So 9 and 4 check out. So the numbers we're looking for here are 9 and 4. Now, here's what we haven't done yet. How are we going to use these numbers? Because that's not my final answer. 9 times 4 is not going to give me this whole polynomial, right? So these numbers are very, very important. But for what? What are we going to do with them now that we know what they are? Let's look back at our problem, right? So you can see what they're doing here. I can't. Okay, never mind. Let's go back. All right, so here let's explain what they're going to do with the 9 and the 4. The 9 and the 4 are going to become x terms that replace the original 13x. So remember, our original polynomial is 3x squared plus 13x plus 12. Well, now we're going to replace the 13x. We're going to take it out, and in its place, we're going to put these two terms. So it'll look like this. We'll have 3x squared, and of course, in the front, we'll have the plus 12 at the end still, but in between where the 13x used to be, we are going to put those two terms, the 9x and the 4x. Now, it doesn't matter which way you put them. You could have put 4x and then 9x. Okay, it's not going to make any difference as long as those two terms are there to replace that one term. So now look, our polynomial has 4 terms in it, not 3. So how do we factor the rest of it from here? Well, all we do is factor by grouping, because remember, when you're grouping, you do only when you have 4 terms. So we group the first 2 terms, we group the last 2 terms, and then we factor. So when we factor the first group has an x in it in common, so I'll factor that x out. And if I divide the x out, I'll have 3x plus 4 remaining. In the second group, both are divisible by 3, so I'll factor the 3 out. And when I divide by 3, I'll have 3x plus 4 remaining. And now you'll notice again that they have the common parenthesis factor. So that's one part of our answer, 3x plus 4. So when I take that out, what's on the outside is x plus 3. X plus 3 makes up my second factor. And this is now my final answer. Okay. So now here's something very important. Okay. It's that factoring and the product go back and forth again. They're hand in hand. If you took the 3x plus 4 and the x plus 3 and you multiply them together, you would end up with 3x squared plus 9x plus 12x. I'm sorry, plus 4x, my bad. Plus 4x plus 12, right? If you multiplied, FOIL, first term, outer term, inner term, and last term. If you FOIL that, you get this. When you combine these two in the middle, you get 13x. So we have 3x squared plus 9x plus 4x, and 9 plus 4 is 13, so 13x plus 12, which is what we started with. So the key to being able to go and multiply it, or to go the other way and factor it, is these two numbers, the numbers that we use in the middle. Those two numbers come from this riddle right up here. You solve that riddle and you find those two numbers, then you can do anything you want, right? You can factor this very easily, okay? So that's the idea. Let's look at our next example. You can see they factored by grouping, they get the same answer, and they multiplied it together to show their work and check their work. Let's look at page 3. Okay, she has a video here working it out, so if my video is not good enough, you can watch hers. She does a decent job explaining it. Like I said, I know her. She's a nice lady. All right, but I'll work out this example that they're showing here. Just so you guys can see it. So we have 8x squared minus 14x plus 5. This looks like a tough one to do at first. 8x squared, what was it? Minus 14x plus 5, minus 14x plus 5. All right. So remember, okay, ax squared plus bx plus c. Okay, let's solve our riddle first. We can't do anything without solving our riddle. So what two numbers multiply to make the a times c value, and the same two numbers that add to make the b value? Now in this case, the a is 8, the c is 5, so 8 times 5 is going to be 40. So I need numbers that multiply to make 40. My b value is negative 14. Okay, so I need two numbers that add to negative 14. So what numbers multiply to make 40 and add to make negative 14? Now I want to point something out right away, that this 14 is negative, which means if this number is negative and this number, the 40, is positive, that the two numbers we're multiplying together are both going to be negative numbers. A negative times a negative will make a positive 40. A negative plus a negative will make negative 14. So let's narrow that down. Our two numbers are both going to be negative. It's the only way we'd get a positive 40, and then we would add to negative 14. Now, again, you could try some options. You can try negative 8 and negative 5. You can try negative 20 and negative 2. But the answer here is negative 10 and negative 4. Negative 10 times negative 4 is a positive 40. And a negative 10 plus a negative 4 is negative 14. So the two numbers we're looking for are negative 10 and negative 4. Now, that's not our answer, but that's very important for us. Remember what we're going to do with those numbers, okay? It's very important you remember how we use these numbers now that we know what they are. We're going to make these numbers x terms, and they're going to replace the middle x term, the original x term of 14x. So remember, we had 8x squared minus 14x plus 5 in the beginning. Well, now I'm replacing that minus 14x with the negative 10x and the negative 4x. Okay, so now my polynomial has 4 terms in it instead of just 3. And what do we do when we have 4 terms? We factor by grouping. Again, it doesn't matter if you put the negative 4x here and then the negative 10x here. It still will factor and work out just fine. So let's go ahead. Put our parentheses around. Don't forget when you have that negative there to include it in parentheses. All right, let's see. The first group they both have x's in it, and 8 and 4 are both divisible by 4, so I can factor out 4x. So if I factor out 4x, 8 divided by 4 is going to leave me with 2, and x squared divided by x will leave me with a single x. And the last part, 4x divided by 4x is negative 1. Since it's the same on top as it is on bottom, that whole thing is just 1, so minus 1. The second group, I'm going to divide by a negative here since that first term is negative. 10 and 5 are both divisible by 5, so I'm going to factor out negative 5. So negative 5 will come out, and we'll have, okay, negative 10 divided by negative 5 will become a positive 2. That x is still going to be there. And then 5 divided by negative 5 is negative 1, so 2x minus 1. And so now we have our final answer is one step away. We have the common binomial. We've got the same parentheses, 2x minus 1. That's the first part of my answer. And then the outside part, which is 4x minus 5, is the second part of my answer, 4x minus 5. And that is my final answer. And if we want to check our work, let's multiply these together to see if we get the same thing we started at the beginning. Remember, we started with 8x squared minus 14x plus 5. Let's see, do we multiply this together and get that same thing? So this is just to check my answer. So to check it, let's do 2x times 4x. 2 times 4 would be 8. X times x makes x squared. That's my outer. 2x times negative 5. That's going to be negative 10x. My inner is negative 1 times 4x, which would be negative 4x. And my last would be negative 1 times negative 5, which is a positive 5. So no coincidence, you'll notice the negative 10 and the negative 4 in the middle. And of course, we combine those to make negative 14x. And we get the same thing that we had started with, right? So that's what factoring does. It goes kind of the backwards way of foiling to get our answer. All right. Of course, you can see they've worked that whole thing out there. I don't know if it helps you the way they've explained it or not. I like my method, my approach. They've got to try it there if you want to try it. Let's move on to page 4. Okay, so factor completely. They got example 1, example 2. Okay, so let's look at example 1. They have x squared minus 12x plus 35. So x squared minus 12x plus 35. So we'll check and make sure I did that right. Okay. All right, remember ax squared plus bx plus c. What's a, b, and c here? Remember, we need two numbers that multiply to make whatever a times c is. Same two numbers that add to make whatever b is. So in this case, a is not really listed here. What number is here, right? It's just x squared. Well, if it's just x squared, that means it's 1x squared. So the a is 1, and our c is 35. So 1 times 35, well, of course, that's going to still be 35. My b value in the middle is negative 12. So what two numbers multiply to make 35 and add to negative 12? Again, since they multiply to make a positive, but they add to make a negative, that means these two numbers must both be negative. All right, so what numbers multiply to make 35? The only thing I can really think of is 7 and 5. Negative 7 times negative 5 is a positive 35. And negative 7 times negative 5 plus negative 5 makes negative 12. So that works. Those two numbers are good, negative 7 and negative 5. All right, so let's put them back. Remember, they're going to become x terms to replace the middle x term. So we don't have to write the 1. Let's write x squared. Remember, minus 12x plus 35. This is the original problem, but we're replacing this middle term with those two terms now, negative 7x minus 5x. All right, and we factor by grouping. So we'll group those. I can take an x out of my first group. That's going to leave me with x minus 7. And in the second group, since this first term is negative, I'm going to divide by a negative, and both numbers can be divided by 5. So I'm going to divide by negative 5. Take negative 5 out. And when I divide, that's going to leave me with a positive x, and then minus 7, since 35 divided by negative 5 is negative 7. And I've got my common binomial, x minus 7, so that's going to be one part of my answer. And then the other part is the outside part. So we have x minus 5. And that's my final answer there. X minus 7 and x minus 5. Now we're going to come back to this because something kind of an interesting coincidence happened here. But let's work out one more example before I point that coincidence out. Example 2 is x squared plus 6x plus 8. So x squared plus 6x plus 8. So in this case, remember, we have to solve our riddle first. So two numbers that multiply to make a times c. Now, a times c, a again is 1, and c is 8. So 1 times 8 is going to be 8. So that's that value. And the b value here is 6. Okay, so I need two numbers that multiply to make 8, add to make 6. For a lot of us, this is a pretty easy one. 2 times 4 is 8. 2 plus 4 is 6. So my numbers are 2 and 4. Now, don't forget, this is the most important part. These two values become x terms and replace that middle x term. So we had x squared plus 6x plus 8, but we're replacing the middle term with these two. So plus 2x plus 4x. All right, now we factor by grouping. So we'll group the first two terms together, the last two terms together. And the first group, both terms have an x, so I'll factor that x out. That leaves me with x plus 2 inside. The second terms both can be divided by 4, so I'll factor 4 out. And then that leaves me with x plus 2 inside. So I have a common factor of x plus 2. So that's half my answer. And then the outside part of x plus 4 to make my other answer. Now, let me point out the very interesting coincidences in these two problems. Now, for both of these problems, I hope you guys can still see that, okay? For both these problems, they both had an a value equal to 1. Okay? Because remember, it was just regular x squared, so essentially remember, if it's x squared, same as 1x squared. So they had an a value equal to 1. And what I also want to point out is the answers. This first one was x minus 7 and x minus 5, and the second one was x plus 2 and x plus 4. Now there's a connection between that, a equal to 1 and our final answer. Let me go back. Notice, in the puzzle here, our numbers were -7 and -5. And what did we have in our answer? We had x minus 7 and x minus 5. Interesting coincidence that those two numbers happen to be the same in our answer, right? And in the second problem we did, our two numbers were 2 and 4. Again, an interesting coincidence because our answer came x plus 2 and x plus 4. So the 2 and the 4 were repeated in our answer, right? It's not simply just 2 and 4. It is x plus 2 and x plus 4, but still, it's not a coincidence that those two numbers happen to be repeated there. Now, let me point that out. This is not what happened in previous problems, right? Previous problems like the 10 and the 4, remember we had -10 and -4 as our numbers up here. Those two numbers did not appear in our final answer at all. Remember, our final answer was 2x minus 1 and 4x minus 5. So those two numbers did not appear in our final answer at all. But it did happen in these two problems, for -7, -5, and for 2 and 4. And that's all because the a value was equal to 1. If the a value does not equal 1, you'll notice on this one the a value is equal to 8. And in the very first one, our a value was equal to 3. If the a value does not equal 1, then that trick, that coincidence does not occur. So this one was not equal to 1. So that coincidence did not occur with the -10, -4. But if a is equal to 1, that coincidence does occur, which sometimes means we can cut out the whole factor by grouping part. And if we know that these two numbers are going to show up in the answer again, then we can just simply go straight to writing our answer. So let me make a demonstration. Let me use an example here. So let's say I have x squared plus, let's say, 10x plus 21. Okay, so of course we're still going to have to solve the riddle, but notice here, of course, that my a value is equal to 1. Since it's just a plain x squared, it is just 1x squared. So let's solve our puzzle. So two numbers that multiply to make a times c. Now again, that's going to be 1 times 21. 1 times 21 is 21. So that's two numbers that multiply to make 21. And the same two numbers that add to make the b value. Our b value here is 10. So two numbers that multiply to make 21 and add to make 10. And that would be 7 and 3. 7 times 3 is 21. 7 plus 3 is 10. So our two numbers are 7 and 3. Now, here's an interesting coincidence. Remember, a was equal to 1. So I'm going to make a prediction. Okay, that since these numbers are 7 and 3, then my answer is going to be x plus 7 and x plus 3. I'm going to bet that those two numbers show back up in my answer. So I'm predicting the final answer right now. I think that's the final answer because I think my shortcut's going to work. So let's try it. Remember, these two terms are going to become x terms, and they're going to replace the middle x term. Let me put that back up there. So we had x squared plus 10x plus 21, but I'm replacing the middle term with plus 7x plus 3x. All right, so remember that we took those two numbers, we've replaced the 10x, we've put them in there. Now factor by grouping. So my factor by grouping, first group has an x in it that I can factor out, and that leaves me x plus 7 remaining inside. The second group, both can be divided by 3, so I'll factor the 3 out, and that will leave me x plus 21 divided by 3 is 7, so x plus 7 inside. So you'll notice I have the common binomial of x plus 7, and I've got the outside part of x plus 3. And look, my prediction came true. My prediction was correct. So what I'm trying to say here is the factor by grouping stuff, you can skip it. You don't have to do this only if the a value is equal to 1. If the a value is equal to 1, then you can go straight to our shortcut. You can solve the puzzle and get the two values, and those two values are going to show up as the final answer, okay? Or in the final answer. Remember, it's not 7 and 3, it's x plus 7 and x plus 3. But still, right, that shortcut applies. Let's just do one more. X squared plus, let's say I've got, let's make it 15x equal to, or not equal, sorry, plus 44. Okay, so here, let's solve the riddle. Remember, note that a is equal to 1 there, okay? So let's set up my puzzle. Two numbers that multiply to make a times c, and the same two numbers that add to make b. Now, a times c. A is 1, c is 44. So 1 times 44 is 44. So two numbers that multiply to make 44, and my b value is 15, and add to make 15. Now, just to cut to the chase here, those two numbers are going to be 4 and 11. 4 times 11 makes 44, and 4 plus 11 makes 15. Now, since my a value is equal to 1, I'm going to go ahead and just write my answer. I'm not going to do the factor by grouping. I know that the 4 and the 11 are going to be a part of my answer. So my answer is going to be x plus 4 and x plus 11. Okay. Now you can go ahead if you want to and double check to see that I'm right. Go ahead, factor by grouping. Make those x terms, use it to replace this, do all that. But I promise you it's going to be this answer. So use that shortcut, but only use it when a is equal to 1. Don't use it if a is anything else. Okay? Because then it doesn't work. But of course, don't forget the x plus part, right? That's kind of important. X plus 4, x plus 11. It's very, very crucial. Okay? Move on to page 5. This one's a whole lot more complicated, it looks like. It's got two variables in it. That one doesn't. That one looks simple. Well, it looks simple now. Okay, so these last two are going to be prime because there simply is no two numbers that will multiply to make it. I'm trying to skip ahead here because I know I've already made a pretty long video. All right. This part has two variables, still works pretty much the same way as the other one. You would still, let's go ahead, 2x squared. What else we had? Plus 19x. You can write there you go, plus 19x y plus 35y squared. Was that right? Let me double check. Yeah, okay. So you kind of do the same thing you were doing before. So let's solve the riddle. Two numbers that multiply to make a times c, two numbers that add to make b. Now in this case, a times c, we have 2 times 35. So 2 times 35 makes 70. So two numbers that multiply to make 70, my b value is 19. All right, so two numbers that multiply to make 70 and to make 19 are 14 and 5. 14 times 5 is 70. 14 plus 5 is 19. Now, that's a hard one to do in your head. So think about that one long and hard, or use a calculator. It would work, though. 14 and 5. But the same rule still applies. This, because our middle term is an xy term, these both become an xy term. So they're still going to replace that middle term. Remember, we had 2x squared plus 19xy plus 35y squared. Those two terms are still going to be used to take out the 19xy and replace it. So replace it with plus 14xy plus 5xy. And again, continue to factor by grouping. So the first group can be divided by 2. Both have an x in it, so we'll factor out 2x. That leaves me with x plus 7y. The second group, both can be divided by 5, and both terms have a y in it, so we'll factor out 5y. And that'll leave me with an x plus 7y. And I still get my same two common factors, x plus 7y, and my last part being 2x plus 5y on the outside. So we still get our final answer. It's the same process, no different at all, really. You still have to solve this riddle. You still take the two numbers to replace the middle number. So since our middle number was an xy term, these two numbers became xy terms, okay? 14xy and 5xy to replace the 19xy. Factor by grouping is still the same exact thing. You still factor by grouping. No difference there. You should end up with the same result. So, let's see what page 6 is. Page 6, you have more practice problems. Feel free to go through these. I'm not going to go through them just because I've already made this video long enough. But go through them, submit your work, check your answers, see how you do, okay? And you have more practice problems here before you take the quiz. If you have any questions, let me know. I can always help you guys out one-on-one. Ask me questions in the discussion or message me, whatever you got to do. I'll see you guys in section 8.4 next. Bye.